Okay, 4.3 is an extension of rational expressions. So we just finished a lesson on multiplying and dividing fractions. So now we're going to add and subtract fractions. If I gave you the problem, well, not that problem. If I gave you the problem 1/2 plus 3/4, what would we have to do there? Do you guys remember? Okay. I hear a bunch of things. Not cross multiply, not divide. We have to add them, but before we can add them, what do we have to know about these two things? Common denominator, right? And so I would say, okay, so 2 is missing a 4. How do I make 2 become a 4? What do I multiply it by? 2. And so I do top and bottom, remember? All right. And then would I have to change anything to the second fraction? No. Okay. What if it was a problem that looked like this? What if you had 1/2 plus 2/3? What would you do? Common denominator between 2 and 3 is what? 6. So I'd have to multiply this one by 3/3 and this one by 2/2. So let's take a look at, these are two different scenarios. Okay, so if you want to write these down, that's fine. But scenario number 1 says that you're only going to have to change one of the fractions. You're only going to have to multiply one of the fractions to get a common denominator. Scenario 2 says both of the fractions are going to have to be multiplied by something. Okay, so there are one of two scenarios that you're going to have. Either they're not going to have anything in common and you have to multiply both of them, or scenario 1 where you can only multiply one of them. So let's put some real life examples. Let's look at example number 1. It says 2 over x plus 3 over x squared. Now, x and x squared are not the same. But could we easily make that first x become an x squared? How do you make x become x squared? Times it by x, right? So I could multiply this first fraction by x over x. And that's going to give me x squared in the denominator. Now, if that gives me x squared in the denominator, do I need to change the second fraction at all? No, because it's already x squared. So we're going to multiply 2 times x is 2x, and x times x is x squared, plus 3 over x squared. So now that your denominators are the same, we're going to rewrite it with one denominator, 2x plus 3, all over x squared, right? Because when we add fractions, we don't touch the denominators once we get them to be common. We don't add x squared and x squared. It's just going to be x squared. So can you combine 2x plus 3 at all? No, you can't, right? I mean, it is what it is. There are no like terms. So this would be my final answer here. 2x plus 3 over x squared. Questions on number 1. Okay, question number 2. It says we have a denominator of x plus 2 and a denominator of x minus 6. Now, remember, yes, they have x's in common, but the entire x plus 2 goes together, right? And so I don't know how I'm supposed to make x plus 2 become x minus 6. So let's look at option number 2 that I wrote there at the top with the basic fractions. Notice that we multiplied each fraction by the other, right? This one by a 3 and this one by a 2. Do you guys see that? I multiplied them by each other. So we're going to do that exact same thing on example 2. I can't make x plus 2 become an x minus 6. So if I can't make it become that, I'm going to multiply it, top and bottom, by the other denominator. What is x minus 6 divided by x minus 6? Not 0, it's 1. Remember, anything divided by itself is the number 1. So we really haven't changed the problem. We've just changed the way that it looks. We haven't changed the value, we've just changed the way that it looks. So what do you think I'm going to multiply the second fraction by?
X plus 2.
X plus 2 over x plus 2. So we multiplied the denominators by each other. Okay, questions on this part before we go on? Yes?
Why can't we do that one by x minus 3?
Because x minus 3, and if you add x minus 3 plus x plus 2, you're not going to get x minus 6. Or if you multiplied x minus 3 times x plus 2, you're not just going to get x minus 6. Okay? Okay, so do you notice in the denominator, I want to show you something. In the denominator, don't you have the same thing? Right? We have an x minus 6 and an x plus 2, and we have an x minus 6 and an x plus 2. Do you guys see that? So we have common denominators now. So to save ourselves some time, off to the side we're going to write LCD. LCD stands for least common denominator. So we're going to use this to represent what our denominator is while we're working through the numerator, so I don't have to keep writing x minus 6, x plus 2, x minus 6, x plus 2. That's going to take forever. So my denominator is x minus 6 and x plus 2. So again, remember that we are simplifying rational expressions, and multiplying them together would actually not be simplifying. It would be the opposite. That's a good question, though. Okay, so we're going to let our LCD be x minus 6, x plus 2. Remember, we got that from what our denominators are now that they are the same. So now we're going to multiply. So if I multiply the numerator of the first one, what is x times x here? X squared. And then x times a negative 6. Negative 6x. And we're going to put this over, instead of writing that x minus 6, x plus 2 thing, we're just going to put LCD here. Again, the only reason we use LCD is so that we don't have to write x minus 6, x plus 2 every time. It's like a placeholder, okay? All right, we have our plus sign in the middle, and now let's do the second side. 4x times x. And then 4x times 2 plus 8x over the LCD. Okay, so we've gone ahead and multiplied. So now we're going to write it as one big fraction. So we have x squared minus 6x plus 4x squared plus 8x. So we're combining the numerators, and we're going to write it all over one big LCD.
I got a question.
Yeah.
I know I'm probably too far ahead, but wouldn't we combine like terms?
That's what our next step is. Yep. So our next step is, what is x squared plus 4x squared? Okay. And then what is negative 6x plus 8x? 2x. Do you see how annoying it would be to have to write x minus 6 and x plus 2 every time? We have that LCD. That's why we use LCD instead. Okay, now before we go forward, it doesn't look like it can combine anything else. Is there anything in common between 5x squared and 2x? What do they have in common? They have an x in common. So I'm going to put an x outside, which leaves me with 5x plus 2, because we're always trying to simplify. And now, instead of writing LCD, what can we write?
X minus 6 x plus 2.
This would be my final answer. Now, the reason that we want to factor that numerator, we pulled that x out, is because sometimes we might be able to cancel like we learned in last lesson. Like if that 5x plus 2 was just an x plus 2, we could cancel it with a denominator x plus 2, right? So that's why we always want to make sure that we factor the numerator when we get finished. We're going to do some more of these to help. Okay, so let's do example 3. Okay, wow, that seems like we're going to have to do a lot of work, right? Like we're going to have to multiply both sides by x plus 3 and then, or by that whole x squared plus 5x plus 6 thing. But before I do that, let's look at what x squared plus 5x plus 6 factors to. Oops. Okay, so can you x factor x squared plus 5x plus 6? The answer would be yes. So what does that become? We have 2 and 3, right? So I know that this denominator is really x plus 2 and x plus 3. Now, does anyone see something interesting? They both have the x plus 3. You guys see that? So this has an x plus 3 and this has an x plus 3. So I'm going to ask myself this question. Look up here at the board as I point. What is this fraction missing that this fraction has? And what would you say? 2. Not just 2, but it has the x plus 2. You guys see how we did that? What is this problem missing that this one has in the denominator only? An x plus 2. That's how we decide what we're going to multiply by. So I'm going to multiply the second fraction by an x plus 2 over x plus 2. Now, are the denominators the same? Do I have an x plus 2 and an x plus 3 with both of them? I do. So that becomes my LCD. So you're going to tell me, and you have to tell me what your LCD is x plus 2 times x plus 3. Did we change the first fraction at all? We didn't, right? So we're going to rewrite the first fraction over LCD. And now I'm going to have to distribute, right? I'm going to do the 5 times x, which gives you what? Plus 10. Over LCD, good. Now we write it one big problem. So I have x minus 1. We have to be really careful. Why do we have to be really careful at this point? The what? The signs, right? This is a subtraction problem, which means I really am subtracting the 5x plus 10, which means I'm going to get a negative 5x. And what kind of 10 am I getting? A negative 10. Do you guys see that? Your negative sign gets distributed. So you have to be really careful there. Now we can combine like terms. So I have 1x minus 5x is what? Negative 4x. And I have negative 1 and negative 10. Negative 11. Now, I have my LCD on the bottom. Can I combine negative 4x minus 11? Can I factor it? No. So negative 4x minus 11 is finished. We can't factor and we can't multiply. So what do we have in the denominator then? What do we actually put in the denominator now? Good. So we change this back to be x plus 2, x plus 3. So once we get to our final step where we can't do anything, that's when we're going to do our x plus 2 and x plus 3. Any questions on number 3? All right, I'd like you to try number 4. Again, you're asking yourself, what is this one missing that this one has? I'll work you through it on the board. We know that the first fraction is missing what? A p plus 5.
Why isn't the second fraction?
Well, we're only talking about, we're not to the second fraction yet. I was just looking at the first fraction. Do you see that the first fraction is missing a p plus 5?
No, because we're not to the second fraction. I don't know.
Okay, let me rephrase that. Do you see that the first fraction, if I want to get these to be the same, the first fraction is missing the p plus 5. It doesn't have it over there. What is p plus 5 missing that the other one has? 3p and what?
Well, it has 5, so it has 4.
Plus 4. Because remember, it's one entire term. It's not just a 3p and it's not just a 4. It's the entire thing, right? Okay, now that I've got you set up, use your LCD. Combine like terms. When you multiply p plus 5 and 4p minus 5, how do you have to multiply that? You're going to have to use the box, right? Or FOIL. Do you guys agree with that? So when you have your p plus 5 and 4p minus 5 up top here, you're going to have to use the box or you're going to have to FOIL. Whichever method you use. What do you mean, all of them?
All 4.
Two terms, yes. Then we're going to have to distribute the 5 to make 15p. Oh, I messed up. Oh, just a second. Keep working. I multiplied the wrong thing. Should have multiplied p plus 5 times 4p minus 5. And then 15p, right? Minus 25. Does that sound better?
Yeah.
Whew. That was rough. I just multiplied the wrong thing. And then we have 15p plus 20 over there, right? On the second one?
On the second one, it's 50 plus
You have 30p?
Yeah, you got 20.
Oh, I'm not. Oh, okay. I'm not there yet. I'm not finished. You're a step ahead of me. So I just multiplied the numerators together. So now I'll write it one time. I have 4p squared plus 15p minus 25 plus 15p plus 20. Now, some people might think that this step that I just wrote down is excess, okay, because you can combine like terms in the step ahead of it. But the problem is when it's a subtraction problem, you have to be really careful about that. Okay, so be really careful when it's a subtraction problem. So 4p squared stands alone. Then I have 15p and 15p. What is 15p and 15p? 30p. And then I have negative 25 and 20. Negative 5. Now, it doesn't look like I can pull anything out of the numerator, 4p squared plus 30p minus 5, but we can double check to make sure that we can't x factor this. So, what two numbers multiply to get a negative 20 and add to get 30? Does that exist? Let's see, 1 and 20, 2 and 10, 4 and 5. That's not going to give me 30 when I add them. So, that can't be factored, and so instead of LCD, I'm going to write p plus 5, 3p plus 4. Does anyone have a question on this one? Yeah.
How do you get a positive 15?
On the first fraction or the second fraction?
The first one.
Because when you are doing, look over to the left where my box is, 4 and 5 is 20, and then negative 5 and p is negative 5. So these two added together is a positive 15.
Yeah, I just messed myself.
Okay. All right, let's try example 5. Now, on example 5, we could just start off by multiplying each side by the other, right? Or we could do what? What is, can we factor the second denominator? What can I pull out of there? A 2. And if I pull a 2 out of there, I'm left with y minus 8. And now, look at our denominators. They each have a what? Okay, but if you don't factor, you're not going to be able to see that. So they both have a y minus 8. So then what's the first fraction only missing? Just a 2, right? Do you guys see that? The first fraction is only missing a 2. If I put a 2 there, then they're going to match up. So I'm going to put 2 over 2. Do we need to mess with the second fraction? No, because now my denominators match. So now my LCD is 2 times y minus 8. Be very careful with your negative signs on this problem. So 2 times 7, 14 over my LCD, minus 7 plus 3y over LCD. Remember, if it's a subtraction sign, we really need to distribute that negative sign. So I have 14 minus 7 minus 3y. If I'm going too fast, speak up, ask questions. So all I did from the second step to the third step was distribute this negative sign. Now I can combine like terms. What's 14 minus 7? 7. So I have 7 minus 3y. Can that be simplified or factored? No. So my numerator is finished. You can write it as negative 3y plus 7 if you want to, but tomato, tomato. Doesn't matter. Okay. Then I'm going to have on the bottom 2 times y minus 8. And please do not multiply that 2 back through. Leave it as is. Okay, we're going to skip number 6. Let's go down and do, let me look and see which ones they are. Let's do number 7 together. Notice it says factor first and then multiply by what's missing. So what is, let's do the easy one. What is x squared minus 1 factor to?
X plus 1 is minus 1.
Okay, so this, remember, is, like Colt just told us, x plus 1, x minus 1. That's what that denominator becomes. No, we got to figure out what the other one's going to be. So then what two numbers multiply to get 4 but add to get 5? 1 and 4. So this denominator becomes x plus 1, x plus 4. Now becomes the part where we're trying to match it up. What do they both have? They both have an x plus 1. So now I'm going to ask myself, what is the first fraction missing in the denominator that the second one has? Do you guys see that? It would be an x minus 1. That tells me that that's what you need to multiply by. So I need to multiply this side by an x minus 1 over x minus 1. Now I'm going to go to the second fraction and ask myself, what is that denominator missing that the first denominator has? So that tells me what I need to multiply each side by. So my denominator has 3 different terms or binomials. You guys see that? They're still all the same. It doesn't matter if they're out of order. So my LCD is x minus 1, x plus 1, and x plus 4. Does everyone see where that came from? Anyone not see where that came from? It's okay to raise your hand. That's the entire denominator on both sides, right? So now the first fraction says you just need to distribute that 2 here and here. Why don't you see what you guys can come up with? Okay? Work it. You know how you need to multiply your numerators, so multiply those together. So I'm distributing my negative sign. Now we can combine like terms. So I have a 2x and a negative 3x gives me negative x or negative 1x. And then a negative 2 and a negative 12 give me
Negative 14.
good. I can't simplify that any. I can't reduce that. I can't factor that. So now x plus 1, x minus 1, x plus 4. Questions on that one? Okay, the only thing we're going to do on number 8 is just get it set up. Okay. On number 8, you have two denominators, but does one of them need to be factored first?
Yes.
That a squared minus 16, right? And what does a squared minus 16 factor to? A minus, difference of squares, a minus 4, a plus 4. So then I'm going to ask myself, is the first fraction missing anything that the second one has? No. Listen to what I said. Is the first fraction missing anything that the second one has? No. Okay, it has an a plus 4 and that's it. So now, does the second fraction miss anything that the first one has?
Yes.
What would that be?
A minus 4.
Excellent.
Good job, everybody.
I know, you sound like a little... I know, I was going to say that too. I wanna vote.
Everybody wants to.
Okay, and so then we would continue this problem, but we're not going to do that for now because now you know what to do. Okay? Any questions on this?